Hello guys, hope you are doing good. So in this session, we'll be exploring how JavaScript runs behind the scene. So throughout the bootcamp, we have learned like how to work with JavaScript, basically the JavaScript syntax and building projects with the JavaScript language. But we didn't get the opportunity to deep dive into how JavaScript works behind the scene. Uh, So having said that, we want to like explore like how JavaScript works behind the scene. Okay, so we'll talk about um, uh, like the JavaScript engine, event loop. Then we'll learn about the async await. Then promise. Actually, you learned all of this concept, but uh, like understanding the mm, JavaScript uh, engine and how JavaScript runs, will actually understand like the core concept of async await, then callback, and also the promise. Okay, so we'll learn all of this by doing like the example, and we'll see how they runs behind the thing. Okay, so I want to just create a new file which is index.js. So this is just a JavaScript file. So if I run it, console.log, let's say hello world. Hello world. Okay, save it. And if I run it, so I have an extension which is probably code runner. Okay. So if you install it, you can just run it. Okay, I can see hello world. So, so you see, I can run the JavaScript codes, but how it runs behind the scene? So we need to explore how it runs. Mostly in other programming languages like the Java, then C, C++, they have a main function. So from that main function, all the codes get executed. But in JavaScript, we know JavaScript is a dynamically typed programming language, high-level dynamically typed programming language. That means you don't need any kind of main function. You can just run from anywhere of your code. So I can run the code and I can see. Okay, so let me show you another thing. If I want to run console.log and print that uh, this object. So this is a special keyword in JavaScript. So if you run it, okay, I cannot see in the VS Code. Let me open. Okay, so I can see it in the browser. As we know already that we can like run the JavaScript in the browser also, right? So in the console, I can run it. So if I run console.log and then this, so I'll see like so many properties like objects, you see. So these all properties are given by the JavaScript, like from the browser. As you can see, you can see the alert function, so many functions we can see from this object. Okay, so yeah, it's given by default. So now we'll see like how JavaScript runs behind the scene. So you see, this is a single line of code. So if you run this, so before understanding how JavaScript runs, we need to understand what are the like components, like what are the components are used to run this JavaScript code. Okay, so mostly, most programming language, there are like interpreter. and compiler, but in JavaScript we have the runtime. Okay, runtime, or you can say the JavaScript engine, right? So in locally, you have to install the uh, Node.js, which is JavaScript runtime that basically runs the JavaScript code, right? But in browser, we know there is a engine, right? So every browser, we know we can run the JavaScript code. As you can see, I can run any code, any code. That means hello, right? So I can run the JavaScript code. That means there is a library, sorry, not library, there is a engine built in the browser, right? So it is called V8 engine. So every browser has their own uh, like JavaScript engine. For the Google Chrome, it is V8 engine. So if I search, okay, let me search yes engine for different browsers. Okay. So this is V8 open source JavaScript engine developed by Google. So it is the Chrome engine. Spider Monkey is for the Mozilla Firefox. So if you use the Mozilla, like you are using the Spider Monkey behind the scene. Okay, then JavaScript core for the Apple. So Apple use like the Safari browser. Uh, you may use the Safari from your phone, but this is the uh, JavaScript engine that is used by the Safari browser. So every browser like use the JavaScript engine. Okay. So for the Google Chrome, it is the V8 engine. Okay. It is the V8 engine. So what is the structure of this V8 engine? So if I just search V8 engine or JavaScript, let's see. Okay. So we have so many components. You can see it has a parser, compiler, and execution steps. But if you consider like the JavaScript engine, like how the code gets executed, you need to understand like the JS engine, uh, which has some components, and those are uh, like the global execution context. Let me draw something so I can run it. Yep. So we can use something. Let's say, okay, then I have another. I can enlarge it and make it another color. Okay. So this is your global. Oh, I can freeze it. Global execution context. Okay. Global execution context. Okay. So this is your global execution context. So in this context, can actually provide here. So this is your call stack, not the global execution context. This is the call stack. Let me write it down. Call stack. Okay. So in this call stacks, when you run any code from your, let's say this code, okay, so it gets executed by creating a global execution context in this call stack. Okay, that means this is the call stack. This is your component, right, from the JavaScript engine. So when you run the JavaScript code, an execution context is created. Okay, so as soon as you run, this file or any code, for this single line of code, an execution context is created. Okay, so that means this code will go to here. Okay, so it has a sequence. So for the first line, it will be stored here. Okay, that means it will be executed from this call stack. Okay, and there is another component which is defined. So it is the callback queue. Callback queue. So you can callback queue. Okay. So queue. Okay. So these are the components you can consider when running any JavaScript code. Okay. So when you run console.log, then this it gets executed in this call stack. Okay, and then you can see the result. Okay? I can see the objects if I run it like hello world, hello world. Okay? So I can see the hello world text, right? That means it goes to this call stack. Okay, so this whole part are combined. This is called the JavaScript engine. Okay, so in this call stack, this like global execution context is created when you run the JavaScript code, and this console.log gets executed. Okay, that is the way. But this component has another job. So this name is I can say it is event loop. Okay, so I can just copy it and I can say event loop. What is the job of this component? So event loop, let's say, let's say you have a for loop. Okay, okay. So let's say you have a set timeout, set timeout function. So we know set timeout is an asynchronous function, right? Because it takes uh like time to get executed. So if I give you, let's say, 1,000, 3,000. Okay, 3,000, and then I can just console something. Ran after 3 seconds. Okay, so if I run, you see after 3 seconds, I will get ran after three seconds. This is the text I'm getting after 3 seconds. So what happens behind the scene? So if there is any asynchronous task, I think you already know what is asynchronous and synchronous. That means this this single line of code, you see 3 lines of code gets executed after 3 seconds. But if I see another console dot log from the end of the code, okay, so what will be the, let me clear all of this. Okay, I can run. Okay, so what will be the output? You'll see hello world, then from the end of the code, and then you'll see run after 3 seconds, after 3 seconds time. Okay, so if I run it, you see hello world from the end of the code, and then you'll see run after 3 seconds. So what is the mm, execution sequence? You see this single lines of code stored here. Okay, first of all, it's stored here. But when it is any kind of asynchronous task, okay, asynchronous task, okay, so there are some web APIs provided by the browser. If you search on the Google web APIs in JavaScript, you will see the fetch API, okay, fetch API, set timeout, then uh, web API. Okay, okay, you see, form history, then storage API, like the local storage, and then session storage. So those are the APIs given by the web browser. Okay, like the fetch. Okay, so those are the web APIs. So set timeout is another API given by the browser. So when you use this set timeout, it like sets on the global execution context. Okay, but okay, but when it is an asynchronous task, so as soon as it gets stored on this call stack, this call stack identifies it is an asynchronous task. Okay, then it immediately goes to this event loop. Okay, that means the this set timeout will be stored. Oops. Oh, I cannot. Okay, I can just copy and I can. Okay, so I can just type and paste here. Okay, that means your asynchronous task will go to this event loop. Okay, this event loop like will wait for the 300 milliseconds, 3000 milliseconds. You will say 3000 milliseconds. Okay, and there is another code you see from the end of the code. It will be, it's just a synchronous code, right? Synchronous code, and it will be stored. I mean, it will be executed from this call stack. Like there will be another global execution context for this console.log, right? That means for this line, there will be another global execution context. Okay, so it will wait for 3000 milliseconds. Okay, after 3000 milliseconds, it will be sent. Okay, let me draw something. It will be sent after 3000 milliseconds. Okay, it will wait for 3 seconds. Okay, so after waiting for 3 seconds, it will like this code will be sent to this callback queue. Okay, that means okay, let me type something. Uh, Send after 3 seconds. Okay, So, okay. So I cannot increase it. Okay. So you can see, but this code will wait for 3 seconds, like from the event loop. Okay. Then it will be sent to this callback queue. Okay. And uh, it will check if the call stack is empty or not. That means when any global execution context is created, for example, for console.log, then there will be another global execution context. And when it will be executed, you'll see the output. That means it will be vanished. Okay. That means there is like no global execution context because the output is already given for these two cores. Okay. That means this callback queue will see that there is no uh, global execution context. Okay. And then this callback queue, okay, after waiting for 3 seconds, this callback queue will send these lines of code into this call stack. Okay. Okay. Then there will be another uh, execution context. Okay, for this set timeout. Okay, that means that this. Okay, I can copy again. Okay, then this for this code there will be another execution context. Okay, so that way you can see the output. First of all, you can see if I type the sequence. This is the sequence, and this is the second number, and this is the third number. Okay, this is the sequence of this code, the execution of this like code. Okay, this is how like the JavaScript works behind the scene. Okay, but okay, so if I run any mm, any for loop, let's say for let oops, let I then 0 and then I is less than, let's say, a big number. So I want to wait for a while. Okay, so I'm giving a big number. Okay, I plus plus. So I'm just commenting out this line. Okay, and I can just do something. Let's say const a 2. Okay, so I'm just doing something. So you see there is a huge number, like that means there will be like um, 100. What is the value? That means you'll see like there will be a waiting time because it has a like significant number. Okay, so if I clear all of this and run it again, you see. Okay, let me increase it. Okay, so if I run it, you see there is a wait to get this value. Okay, this is synchronous. This is not asynchronous. Okay, this is synchronous. Synchronous code. I want to increase more so that you can understand. Okay, run it. As you can see, no from the end of the code. That means you see for this for loop, I cannot see this uh, output. Okay, you see, I'm waiting to get executed for this for loop. Okay, this is synchronous. Okay, but this is asynchronous. Okay, when it is asynchronous, it goes to the event loop. Okay, any kind of asynchronous code will be shift to this will be shifted to this event loop, but not in the call stack. Okay, so that is the catch from this uh, code. Okay, any asynchronous code, you see, this is synchronous. Okay, this is CPU intensive task. Okay, your memory is being used for this uh, lines of code. Okay, this is CPU intensive task, and this is asynchronous task. As you know, like uh, like the set timeout, set interval. So those are the asynchronous tasks. So you may ask, what are the asynchronous tasks? Like the API call is an asynchronous task. So when you use the fetch, then promise, then async await. So all these things are asynchronous tasks. Okay, so we'll deep dive into this async await, then callback fetch. Now you see, after like 1 minute, I can see this lines of code. That means when you run these lines of code is getting stored in this call stack, not in this event loop. Okay, so I can paste it. Oh, okay. So when you run any kind of for loop, that means the CPU intensive task, it gets executed in this call stack, not in the event loop. So event loop is just a gatekeeper. You can say the gatekeeper. It just checks any asynchronous code is given or not. So from this call stack, the asynchronous code will be shifted to this event loop, and then event loop will just wait for that specific time. Okay, and as soon as it finished the waiting time, it just sent the code in this callback queue, and callback queue just checks is there any execution context in the call stack or not. So if the callback queue finds that there is no execution context in the call stack, then it sends in the call stack. Okay, this is how you can see the output in your code. Okay, I think you have understood everything, but if you don't get, you can see another visual. I just open it, which is this one. Okay, so if I run it, okay, so you see this is the call stack. Okay, and event loop is just checking the call stack is empty or not. Okay, then all the tasks are being sent to this call stack. So this is how the asynchronous task uh, get executed. Okay, so I can share it on our channel. Let me share. So I cannot type anything. So I'll be sharing on the channel so that you can get this emoji, or you can just search like the mm, JavaScript engine in the Google. Okay. Okay. That's it for the uh, behavior of JavaScript running on the browser and event loop. So see you in the next videos. In the next video, uh, we'll be exploring the callback, then the promise, and then async await. Thank you.